in terms of alcohols, so this is the last bit for the standard levels. Okay, so alcohols combust. So I've got a beautiful page here of combustion of alcohols. Again, remember, incomplete gives you carbon monoxide and water, could also give you carbon as well. And complete is always with carbon dioxide and water. As I mentioned with alkanes, the products of complete combustion comes up a lot. It's one of those basic reactions that they'll always ask you. The other thing alcohols do is they get oxidized. Before we look at oxidation, it's important just to be able to classify alcohols. So methanol is kind of a bit of an exception to this classification, but if we look at the rest, primary alcohol is when you've got a carbon bonded to an OH, and that's bonded to one other carbon. So that's primary. Secondary is when the carbon bonded to the OH is bonded to two other carbons. And a tertiary is when a carbon bonded to OH is bonded to three other carbons. So really makes sense. It's for once scientists were very smart in naming them this way. And it makes life easier in terms of oxidation. So, oh yeah?
If we had to write down the equations for the combustion of alcohol ourselves, how would we determine which alcohol would combust partially and completely?
Okay, so whenever you have to write equations for combustion of alcohols, they're only going to make you write equations for complete combustion, because incomplete is a nightmare because it doesn't always balance out. You will have some carbon in there as well. Whenever they mention combustion, you can basically always assume it's complete when you're writing down an equation. So you're always going to have to write it combining with oxygen and giving carbon dioxide and water. It's good to be aware that you get incomplete combustion as well, but it's not an equation that you're ever going to have to write out in the exam for that. Okay, on to our oxidation. So oxidation of alcohols, again, reagents. You're going to need heat, and you're going to need acidified potassium dichromate. It's important you mention it's acidified because that does change the whole reaction. And it's also important you know it goes from orange to green. You might have been given another one. I think it's potassium permanganate that can also do this. I'm not sure. But if your school gave you another one, there is another one out there. I just learned potassium dichromate, so that's the one I teach. Okay, and from there it's quite easy. So your primary alcohols, so this carbon that's bonded to one other carbon, with limiting oxidizing agent, so the O in brackets means oxidizing agent, which is this acidified potassium dichromate. If you've got a limiting amount of that, it will become an aldehyde. You'd also have to distill it. For those of you that don't know what distillation is, basically you just heat your primary alcohol, and as soon as it becomes an aldehyde, you filter it off. It's complicated apparatus. It doesn't really matter. You don't need to know much more than that. But basically, as soon as the aldehyde is made, it's taken away from the reaction. If you react the primary alcohol with excess oxidizing agent, so excess acidified potassium dichromate, you get a carboxylic acid. And this guy you have to put under reflux. Now, reflux is basically you heat it, the primary alcohol will boil, it'll evaporate, change into this carboxylic acid, and then condense back down and go back into the solution and then be reheated again. The reason it's in reflux is because not all the primary alcohol will go straight to the carboxylic acid. Some of it will go to the aldehyde. So the point is the aldehyde would then recondense again and be reheated again, and so then hopefully change all the way to the carboxylic acid. It's basically just a way of ensuring you only get the carboxylic acid. Secondary alcohols, they only do full oxidation with excess oxidizing agent and reflux to a ketone, and your tertiary alcohols don't do anything. So again, kinds of questions that come up on this is basically mostly in a reaction scheme. So they'll say, for higher level, for example, they might say an alkane goes to a carboxylic acid. How does it do this? Well, the alkane we've just learned can do free radical substitution. So it could become a haloalkane. The haloalkane will then undergo SN1 or SN2 and become an alcohol, and then the alcohol will be oxidized to a carboxylic acid. So those are the kind of things that come up. For standard level, it's much more obvious. So they'll say, this alcohol goes to a carboxylic acid, give the reagents, or if I put this alcohol with these reagents, what is my product? Those are the kinds of questions about standard level. Do you have a question?
Yeah. Can you just quickly explain reflux again?
Yeah. Okay. 1 second, let me actually just get a picture of reflux. Reflux, in all honesty, it's almost like when you get, you know, the like stomach reflux is basically it comes back up and then you swallow it back down, which is really gross. But that's basically all you're doing just in the lab. Let me find, okay. We're getting a full-on picture of the apparatus. Okay, so this is my reflux thing. So you're heating your solution in this beaker. As it heats up, it goes up this tube. And let's say we've got a primary alcohol, it's turned into an aldehyde. But we want to make it a carboxylic acid. We want it to fully react. So to ensure that, it'll go up this tube, and rather than leaving, it's then just going to condense again because we've got this water that makes this surface cold. So it'll condense back down and it'll go down into the beaker. It'll then heat up again, and this time it'll have enough energy and enough oxidizing agent, and it will then become the carboxylic acid. Carboxylic acid might also condense back down and go back in the beaker, but it can't react any further. So all reflux does is basically, it makes sure everything is fully reacted, so you only get your carboxylic acid as a product, rather than a mixture of carboxylic acid and aldehyde, which you don't want, because then you'd have to purify and it's just a bit of a mess. So this is all refluxes. The only situation I can see reflux actually coming up is with that experimental question in your third paper. Usually they don't actually ask for a definition of reflux in terms of alcohols. Does that make sense? No comment. Okay, cool. Hopefully that makes sense.
As one more question.
Yeah.
Could you expand on the conditions needed for fractional distillation, i.e. what temperature?
Oh, okay. Temperature-wise for distillation, really depends on what kind of alcohol you've got. If you've got a small alcohol, it's going to make a small aldehyde, so it's going to have a very low boiling point because those intermolecular forces are going to be weaker because it's just smaller. So you'll need a lower temperature. Whereas if you've got a bigger molecule, it'll have stronger London dispersion, higher boiling point, so you need a higher temperature. So there isn't like a one temperature works fits all. And needless to say, you're not going to be asked for the temperature in the exam. Any other questions? No. Okay, cool. So before I lose the standard levels, I've just got a few questions here, which sadly won't work quite as well without my writing techniques, but hey, we'll just go through them quickly. It's for higher levels as well. Higher levels will have these questions, so don't switch off. Okay, so the first one, how many alcohols have the general formula C4H10O? Now, the way I would do this is I would basically just draw out all the different alcohols. This could be very time consuming, so you got to do it in a clever way. And basically, I would do the 4 carbons in a row, then put the OH on the end, and you could also put it on carbon 2. So that gives me 2 ways. Then I could draw 3 in a row, 3 carbons in a row, with 1 carbon coming off the middle. And then again, there are 2 ways. You could put the alcohol coming off the end, off the end or the middle carbon. So the answer here is B. The important thing to take from here is just do things methodically. In the exam, you'll be panicked, you'll be stressed, you're bound to just, when you see this question, just start drawing molecules. So it's important that when you're doing practice papers, you always do a logical, you always use a logical route to answer these questions. Otherwise, you're going to waste too much time. General formula of alkynes. Now, the reason I've done this is because a lot of you might just draw the first alkyne. So that's 2 carbons with a triple bond in between and 2 H's. And you might think, oh, that's got 2 carbons, 2 hydrogens, it's CnHn, it's A. If you were to draw the next alkyne, which has 3 carbons, you'll actually find the formula is B. So basically, a lot of the other options in the exam. Okay, right. Okay, if I finish 24, so basically the important point is that the IB always put in sneaky questions where the other options are kind of basically traps for people. So do always think, okay, am I sure about this? Have I tried, various ones in the series, etc., etc. Okay, going back to question 23, the easiest way to explain this for any of you struggling to draw it is just to get them up. So the first one is going to be butan 1-ol. So that molecule looks like this guy. So this guy is butan 1-ol. That is option 1. The other option is if we then move this hydroxide and put it on carbon 2 over here. I'm not going to draw it because it's the same, but it's basically butan 2-ol. So that's 2 options. Then the third option is 2-methyl propan 1-ol. And that guy is going to look like, let me get it up, this. Okay. It's going to look like this guy. So that gives us 3 options. And the last option is if I then move that hydroxide and put it on the central carbon here instead of this hydrogen. So that would then be 2-methyl propan 2-ol rather than propan 1-ol. And so that's how you get your 4 options up here. Again, 3 catches a lot of people out. So it is smart to just think, okay, is there any way I could make 4 before we move on? Cool. 25 here is just a question on the alcohols. So which one can both be esterified and turn acidified potassium dichromate green? So the important thing here is the only thing that can turn it green is an alcohol. So it can only be A or C because it has to end in OH. It can't be A because if you draw out A, it's a tertiary alcohol. So it's got to be C.
It's just a bit difficult seeing the options. If you want to either make it bigger or read them.
Is that clear? As the numbers is really poor. Yeah. Okay. So the first guy is 3 CH3s with a COH. So it's an alcohol, but it's a tertiary alcohol. The second guy is CH3, CH2, CO2H. So that's a carboxylic acid. So that's not going to react with potassium dichromate. The next one is CH3, 2 CH3s with a CHOH. So that's going to be a secondary alcohol. So that will react with potassium dichromate. And it can also be esterified if you react it with a carboxylic acid. And the last one is CH3, CH2, CO, CH3. So this is a C double bond O in the middle of the molecule. So that's a ketone. Whereas if it was at the end of the molecule, it would be an aldehyde. So also linking back to when we were discussing like how do you remember all these functional groups, you can very easily go down all these molecules and name all their functional groups. And that's good practice in itself. Even though it's not answering the question, it's just good practice beforehand. Okay, the last thing is reaction between ethane and chlorine. And
how do I calculate the general formula for an alkane for question 4?
Oh, okay.
Sorry.
No, it's fine. Okay, for an alkyne, calculating the general formula. Sorry to be going backwards and forwards. The questions are just slightly out of sync. What you have to do is, and the easiest way, the way I did it, was I just drawed the first 2 alkynes. So if I get that up. So the first one is just ethyne. And that one looks like this guy, which is coming on screen in just a second. This guy, ooh, a little bit big. So the misleading thing is that in the exam, if you only draw this one, you'll think it's option A. Option A is CNHN, because at the moment you've got 2 carbons and 2 hydrogens. So that's why I'd always recommend that you draw the first 2 to make sure that you've exhausted your options, basically. First 2 should be enough. If you really want to be safe, do the first 3. So the second one, as I'm sure most of you know, is propyne. So that's when you've got 3 carbons in there. And that one looks like this guy. And this guy you'll see isn't CNHN, because otherwise you'd have 3 carbons and 3 hydrogens. You've got 3 carbons and 4 hydrogens. So then I'd look at the next one, B, which is CnH2n-2, and that fits both of these. So I'd say, yep, that looks right. CnH2n doesn't fit 1 to begin with, and CnH2n+2 doesn't fit 1 either. So that's how I would do it. If you're good at memorizing, you could also just memorize the general formula. In all honesty, you have plenty to memorize, so it's a bit of a waste of brain space. Okay, so that's 24. Last one here, 26. Which mechanism reaction between ethane and chlorine in sunlight? Sunlight, remember, is a source of UV. Ethane's an alkane, so it can only combust or do free radical substitution. So it's just got to be A. You don't have free radical addition anywhere in the syllabus. You don't have electrophilic substitution either. But you do have electrophilic addition, which is in alkenes. So just make sure you really keep these concepts separate in your head, so you don't get confused with these questions. Okay, another 3 questions. Which is not a possible product when propane reacts with chlorine? Again, this is just looking at free radical substitution. So usually our product is C, C3H7Cl, because that's just when the alkane becomes a haloalkane. But remember, some Cl2 will be left unreacted, so that is a potential product. B, you can't read it, but it's basically just 2 propanes coming together, which again, remember, it's a possibility, because if you've got 2 propyl free radicals, they will just combine and make that molecule, so it's got to be A. Features of successive homologous series, this is just learning. We said it's similar chemical properties, same general formula, differed by CH2, so it's all 3 in D. And the last one, this alcohol can be oxidized under reflux. Deduce the structural formula of the final product. So the important thing is, first ask yourself, is it primary, secondary, or tertiary? This guy is primary, because the carbon with the OH is bonded to one other carbon. And it's heated under reflux. So it's going to go all the way, and it's going to form a carboxylic acid. The color change is always orange to green.
So we're just asking if the answer was for propane.
For what? Which one?
The propane one.
Propane question. This 27. Whoever's asking the question, 27.
27. 27.
Yes. Okay. The answer was A. You never ever make hydrogen when you react propane with chlorine. Yeah, because B you get when you get 2 of these propane molecules combining as free radicals. C you get when the propane combines with the chlorine, and chlorine is just, sometimes it's just unreacted. So hydrogen is the only one you'll never produce. All good? Any questions? Okay. Oh, fantastic. Glad you got it. Okay, this is where I say goodbye to standard levels, because I'm just going to quickly go over nucleophilic substitution for those of you who wanted it.
I do have one more question.
Okay, hit me with the question.
Why would you never produce
Okay, why would you never produce hydrogen? Because you either have a haloalkane, a halogen free radical combining with a hydrogen. So that's always going to be an HCl or an HBr. Or you'll have an alcohol free radical combining with a halogen. So that'll form your like CH3Cl. You're never going to have a hydrogen free radical reacting with another hydrogen, fundamentally just because hydrogen free radicals are far too reactive. It's just too unstable. So it's incredibly unfavorable for it to form. So it's just never going to form a free radical. So you're never going to get the reaction that would make hydrogen in this scenario, if that makes sense, which hopefully does.